I'm going to use some statistics presented in problem number 6 in section 3.4 to illustrate a connection between the empirical rule, mean standard deviation, and z-scores. Now, if you recall, the mean is typically used for symmetric distributions more often, in particular bell-shaped distributions like this one. So mean and standard deviation then being associated with z-scores would often lead you to think of this bell-shaped distribution. Now, the median and the interquartile range, the range, quartiles, percentiles, those are all things that are often used when the mean is not a very good measure of center, so in particular for skewed distributions. So for this example, what I'm going to do is talk a little about the mean, standard deviation, and z-scores in conjunction with this bell-shaped distribution. So what I'm going to do is I'm going to label this as though we're talking about the empirical rule using the mean and standard deviation that are given in this problem. With a mean of 2600, I'm going to put that right in the center here, 2600. And then if I go up in increments of 660, then I would be labeling these points on my curve 3,260, 3,920, and then when I get to 3 standard deviations above the mean, I have 4,580. As I go down from the mean, I am again going in increments of 660 down from the mean. So 1,940, 1,280, and 620 would be the labels on my tick marks down here below the mean. Now what I've actually done here is I have labeled the z-score increments, and the z-score, if you recall, is a measure of how many standard deviations from the mean. So when you mark these increments, what you're doing is marking off the integer z-score values. So a z-score of 0 corresponds to exactly the mean. A z-score of 1 would correspond to the value exactly 1 standard deviation above the mean. So I can label 3,260 as a z-score of 1, 3,920 a z-score of 2, and 3 standard deviations above the mean, I have a z-score of 3 corresponding to 4,580. As I go downward to the left side here, I have a z-score of -1 corresponding to 1,940 because I'm 1 standard deviation below the mean, and a z-score of -2 corresponding to 1,280, 2 standard deviations below the mean, and a z-score of -3 corresponding to 620, which is 3 standard deviations below the mean. Now, the important thing about the empirical rule is that it reminds you that 95% of the data is found within 2 standard deviations of the mean. In other words, z-scores between -2 and 2 would give you the middle 95% of the data. Now we have a general rule that if the z-score falls above 2 or below -2, then that would be considered an outlier. And the reason for that is that those outliers, those z-scores above 2 and below -2, fall in the most extreme 5% of the data. In other words, not in the middle 95%. So the bulk of the data is here within 2 standard deviations. The outliers are outside of that. And so we can see the direct connection between the far left and the far right of the data values and the extreme z-scores. And incidentally, anything with a z-score of less than -3 or above 3 would be considered an extreme outlier.